Okay, so good morning, everyone. I hope everyone is okay. Our topic for this time is about the relative motion analysis. So before we continue, let's recap danay kung ano na ang naton nga na-discussan for the past uh, weeks. So generally, we had discussed about the three most common types of coordinate systems no? Under general curvilinear motion. One is the rectangular or the Cartesian coordinate system. Second is the tangential and normal coordinate system. And the last is the polar coordinate system or the transverse and radial axis. So this time, our focus is on the relativity of motion, the relative motion analysis. It means this time we're going to have a motion that is relative to some kind of observer or some kind of observer that is also moving. But because previously all we had is absolute motion, position, velocity, acceleration, all of them are in terms of absolute the terms. For example, absolute position of object B with respect to the origin, the absolute velocity of a car, or the absolute acceleration of a person. So all of those, no, ang ating consideration is absolute motions lang, absolute lang na analysis. This time, we're going to confine our study on the relative aspect of the motion. So what is the advantage of this type of analysis? There are two advantages. One is that not all types of motion, no, it's not possible to, or it's not convenient to describe all types of motion in a fixed reference frame. Okay, there are particular motions that can be easily described or can be conveniently described or can be measured easily and conveniently using a reference system that is moving, I mean a relative reference frame. Okay, just to give you an example, an actual example, let me copy something sa ating virtual board. This one, no, meron sang mid-air na refueling, bali from one aircraft to another aircraft, na refueling sa aircraft. So in this, ano, it is very critical that the two aircrafts must maintain a zero relative velocity. Because if hindi, no, hindi siya ma-maintain ang aton nga ang ilang gusto nga matabo nga, which is mag-fuel siya. Even though the two aircrafts are moving at very, very high speed, but since the two aircrafts have the same or almost zero relative motion, so it is possible na mag-refuel sila ng mid-air. So this is just one application of relative motion analysis. There are, of course, ton of ng engineering problems na pwede ma-describe or ma-apply using this analysis. Okay, so let's dive in sa ating topic. Today is week 5. Our topic is relative motion analysis. Relative motion analysis. Okay. So let me draw something on the board. Wala. So for example, this is our fixed reference frame. This is the X, this is the Y, and this is the Z. because this is the origin, and you are at the origin for convenience. Now, there's someone that is moving, okay? So, may araw sa yung reference frame. We call it x prime, y prime, and z prime, okay? This one is, you are the fixed observer, and this one is the translating observer. Translating means it is moving in a straight line, but has no rotation. Our discussion is only confined to translation, but no rotation, okay? So, mali ito nga limit sa ating discussion. And the second one is, it is only confined to plane motion. Okay, so we're only going to focus our discussion on these two restrictions. Okay, so there is something moving on in front of both of you. For example, in a curvilinear manner. So ito siya galin. So what ang path? This is the trajectory. Okay, we call the person let's just call it B, ball B. Okay. Now, the position of the ball B with respect to two observers are different, right? Especially the fixed observer is not moving, and the translating observer is having also its own motion. We don't know kung ano yung motion, basta it is moving one. So our position, the position of B with respect to our fixed observer is this. Oops. This we call RB, the position of B. And the position of B with respect to the person at the translating observer is, of course, RB slash A. RB slash A means the relative position of B with respect to A, we call the person of the translating observer A. This is O, this is A, for example. So RB slash A means the relative position of B with respect to A, or the relative position of B relative to A, relative to the person on A, or relative to the reference on A. Now, the person that is also having emotion has position with respect to the fixed observer, and we call it RA, because that is person A with respect to wala siya, RA lang. RA and RB are absolute positions, and if wala agad isang slash O, for instance, it means these are positions that are referred to the fixed reference frame. So understood na siya nga /0 /O na sa RA/O, RB/O, meaning they are referred to the origin at O. But it means lang na absolute is lang position. But of course, there's really no absolute reference frame. But for the sake of our discussion, let's assume that there exists a fixed reference frame. Okay. Especially if the fixed reference frame bala is ang iyang size is so huge compared to other moving objects. Example, the Earth now. Of course, we know that the Earth is moving now. It is rotating, it is revolving. No? But all objects, since they are very, very small, or ang ilang size, are negligible compared to the Earth, then ang assumption that the Earth is fixed is a very good assumption naman. Ang aton nga observation, aton nga measurement, ang aton descriptions are very accurate with respect to the Earth. No? Of course, kung i-refer mo sa laing mga reference frame is pwede siya maglain as long as negligible na siya within sa Japan sa accuracy. Okay, so we now made the relative positions and absolute positions of A and B. So looking at the graph now, looking at the position vectors rather, you can say that RB is the vector sum of RA and RB slash A, because this row head to tail, head to tail, head to tail, polygon method to add the vectors geometrically, meaning RB is equals to RA plus RB slash A. Di ko scroll down now. What happened? I think I have to enter to ready na. Okay. So going back here, let's transpose RA. Finalize our equation. RB slash A is equals to RB minus RA. So this is our very first equation. The relative position of B with respect to A or relative to A is equals to the absolute position of B minus, of course, vectorially by the absolute position of A. Okay? Hindi ka maka-add or hindi ka maka-minus if ang mga vectors are not on the same axis. You have to be on the same axis then before ka mag-operate sa vector na operation. So, from this, we have position, para makakuha sa velocity and acceleration. We just need to derive with respect to time. So, the relative velocity of B with respect to A, in this case, we have B slash A is equals to VB minus V. The relative velocity of B with respect to A is equals to VB minus VA. And lastly, the acceleration of B with respect to A is equals to acceleration of B minus acceleration of A. Equation 3. Okay, so that's it. Wala siyang nadugang sa atin ng formula for this type of analysis. Except that these equations can be used to whatever reference, whatever coordinate system that you're using, maybe rectangular, polar, or tangential. Because notice man, aton nga subscripts are just B and A, and B and A are objects in the space, diba? They do not refer to any particular type of axis, like tangential, radial, transverse, or XYZ. Therefore, these equations pwede pa siya specifically tailored to specific nga coordinate system. Okay. Although wala pa kami nakita sa problems nga outside sa rectangular coordinate system. Kaya nga kung example 3 sa is only confined to rectangular coordinate system. I don't know if I have problem na sa tangential or I'm not sure if that pwede rin siya sa tangential ang 1.705x. So most of the problems na confined siya sa rectangular coordinate system. Although it is possible din nga magamit siya sa other coordinate system. Okay? So ano pa ang pwede na madugang as a theory? Okay. So let me have give you an actual specific scenario. Example, may duwa ka bus or any jeep na lang. Okay? So magnetic na sila. Minus Larida. Ang iyong mga classmate, ari siya sa sulod. So yeah, ari ka din. Okay? So this distance is malaki. Gamay lang distance like 0.5 meter or 0.3 meter nga pwede lagi lumpas ng mga classmates sa buto. Okay? Malumpat siya, malumpat. Wala problema. Pag ang velocity sang ini na bus 2 kag bus number 1 are equal. Equal lang. The same. Pag ang motion is smooth, very smooth. Wala masyado ka fluctuate, wala masyado ka vibrate. Ang dalan, ang tanan is very smooth. As if do wala lang vibration. So may araman gamay. Okay? So sometime later, ang bus, of course, na 1, ang bus na 2, na gano'n ay, nag-move na. Ikaw, of course, araw. Japon, pero ang imong classmate, nakatumbo na. Okay? Then may repeat mo classmate, siguro. Yalan, tao lang sa inyo. Okay? Kumbaga mo na siyang B, mo na siyang O, mo na siyang A. May observer ka nga A, tapos ang object is buong B, hindi mo pala siya person para may ara sa isang motion. Okay. So according sa observer nga da sa buwa, which is area, ikaw. Ang tumbo sa classmate mo, kuda ako iya, huli mo. Kita yung grabe nga tumbo sa classmate mo, kuda ako. Pero ikaw yung harap sa sulod, sa bus, kita mo siya, gatang sa loob. Hindi ka magpati. Kasi hindi lang gamay lang yun, daral yan kita ko yun. Okay. It's because nga ang inyong reference frame, linay, siya fixed. So yeah, yung movement. So ang inyong observation is correct. With respect sa imo yung galing nga reference frame, with respect sa imo point of view, with respect sa imo yung outlook. While ang imo classmate yan, ang iyong observation is also true. But again, with respect sa iyong reference frame. So pareho ka mo check to, hindi ka mag-away. So this is an example of motion nga two persons can have different opinions on something or comments on something, even though ang ilang observations are perfectly valid and exactly, and not exactly, but equally true. Not exact, of course. Kaya ang isa yung observation, yung isa yung grabe, ba't ako dapat lumpat, diba? It's because yung person, B, has the same velocity with bus 1. No? Of course, for example, B, ang B2 is running at 10 miles per hour, and B1 is also running 10 miles per hour. Even though the person B at bus 1, at the top of bus 1, is having no motion, of course, the relative velocity of person B with respect to bus 1 is 0. But the absolute motion of person B with respect to the ground, with respect to the observer outside, is equal to 10 miles per hour. That's why he was able to jump at this far. It's because nga ginabuligan sa isang bus 1. Initially, mayroon na siya 10 miles per hour even though nga 0 ang speed on top of bus 1. Pag tumbo yan mo na, given ang distance is matumbo man lang, wala yung problem na mahimo yan. Okay. Let's generalize this scenario na. Let's remove the bus. Ano na lang diso, ara ka lalalo. Aram na isa mo da kamigo. Okay? Para may distance na pwede matumbo. Tapos amigo niya raman sa man. Tapos, of course, wala ka mo nag-move. Obserbaran lang yan sa amigo mo sa ang ground, wala man binag-move. No? Thankfully, wala nag-move ang ground. Yung tumbo mo niyo, yung tumbo mo lang. Ara ka na sa mo. Okay? So, wala siya kinalain sa inyong scenario. Ang inyong scenario is because nga, ang surface ng Earth is also moving at around 350 meters or feet per second. I forgot. So, tama siya kasi gasi kirama. Dito mo siya very smooth, no vibration. Pero, ang ang scenario are very much the same. Imagine mo lang daw may buo daw up to the core of the earth. Pero mo Japan, matumbo mo siya, it's because of the same exact na principles. Nga ang mga relative velocity is zero, but you and the ground have the same absolute velocities. Okay, so let's do our first sample problem. So